So my name is Nwoye. I'm a senior data engineer with the NHS. And today we'll be discussing what it means to give your organization a competitive edge in this AI era. And it's a very interesting topic, given that AI is a hot topic today and everybody's trying to understand how they could implement AI into the organization process, especially in the data space. And this is all we're covering today, how to start that process and what it means to do it very well. Now, over the past few years, we've seen a surge in AI assistant tools promising self-service analytics. Ask a question to say any question at all of your data and get an answer. I know we all want that capability, but anyone here that has used tools like Databricks Genie, Power BI Copilot, or even Tableau GPT, we recognize that they excel at entry-level analytics such as report summarization, KPI retrieval, dashboard creation, etc. But while these capabilities lower the barrier for accessing data, they don't actually provide a lasting competitive edge for your business or organization. And the question becomes, how do we get to that point where we could perform advanced analytics using AI and begin to treat data as a product? Over the next 45 minutes, we're going to discuss these three key topics. First, why the typical AI architecture limit advanced analysis? Secondly, what would a better self-service approach actually look like without exposing live or sensitive data? And what are the benefits it brings to your organization or business? And lastly, what you can start doing today. Now let's get into it. So what we have on the screen is a typical architectural design behind most AI assistant tools. For the purpose of this session, we are going to use the Power BI Copilot. So let's quickly walk through the prompt process. Everything starts with the user's prompt. The user makes a prompt, then the Copilot analyzes the intent behind that prompt. And it does this by intent classification. A good example of this will be if the user's prompt contains the phrase like show me, the Copilot is going to classify it as a visualization prompt. Now, for the next stage, the Power BI specialist or analyst would have prepared a semantic model, which the Copilot is going to consult to perform what is known as grounding. Now, during this process, the Copilot retrieves known measures and columns it needs to answer that prompt. So if you're not familiar with what the Power BI platform looks like, this is what the semantic model actually looks like. It shows the relationship between tables, how they are related in that sense. Now back to the grounding process. During this process, the Copilot is going to, as I said earlier, retrieve all those known measures. So if your company has a particular way of calculating net profit or net loss, it's going to retrieve those measures. But the most important thing there is that those measures would have been defined by Power BI specialist or analyst. And it's also going to retrieve the columns it needs to answer that prompt. Then what it does next is to create a new or generate a new prompt, which it's going to pass to the large language model in this form that we're seeing on the screen. So you have the system, you have the context, you have the measures, you have the relationship, and then the user's question. Now the large language model takes this prompt and generates a final result, which the Copilot validates and also execute it against the database engine. Let's say it's a query and it needs to return results. Then it generates a dashboard in this case and supplies it to the end user. Now, this architecture works, but only to a point. Let's quickly look at some of the limitations of this architecture. First, the large language model is treated like a function. Pass parameter, get an answer. But here's the catch. The large language model itself isn't trained on your business data, so it doesn't understand the complexities associated with your business data. So you can't just provide it with table relationship like this architecture or the architecture we saw is doing and expect it to perform advanced analytics. You have to give it a little bit more context. The second issue is painful scalability. Very good example of this will be the NHS. In the NHS, a single NHS trust can have over 1,000 tables when you account for all the different assessment forms. Now imagine having to create and maintain a semantic model across those tables. That can quickly turn to a very complex task to manage. And what is even more painful is that you're doing all this work just for the co-pilot and a few technical people that understand the semantic model. Another limitation of this architecture or the pain of this architecture is the platform lock-in. Let's say Amazon or OpenAI or Google emerges as the winner in this AI supremacy war, because it's fairly too early to say that this company or this provider will be the winner. So let's say any of these companies emerges as a winner and you had to migrate that tightly coupled semantic model from the Power BI Copilot to that platform. That's like redoing the entire job all over again. And what is even more painful is that you're moving from one platform just to get locked in another platform. And lastly, the architecture increasingly treats data as a byproduct. When in real sense, data should be treated as a product that shines the light on the business problems and opportunities of the business. And for data to be treated as a product, it has to be accessible, it has to be trustworthy, it has to be understandable. Now, the architecture does a very good job making it accessible, but it doesn't help with the trust and understanding of the data. So I'm not saying that the architecture, the semantic model in general is wrong. What I'm trying to drive at is that it doesn't provide enough context to perform advanced analytics. That brings us to a more important question. What would a better self-service approach actually look like without exposing life or sensitive data? But before I go into that, I will digress for just a moment and explain what I mean by giving the large language model enough context to perform advanced analytics. A very good example of this will be the Microsoft 365 Copilot. Has anyone ever noticed that when you give the Microsoft 365 Copilot access to your entire Microsoft environment and prompt it to draft a response to an email, it tends to do a fairly good job. This is because it's performed a more advanced, comprehensive grounding process by consulting multiple documentation in order to build that context around the email and generate a fairly good response. Now, the same idea powers the Google Notebook LM. For anyone not familiar with the platform, it allows you to upload your data source, which the large language model is going to use to answer your prompt using specific context instead of generic knowledge. Let's quickly look at a very simple example that explains this idea very well. Suppose we have two tables, the patient activity table and the care coordinator assignment table. And we needed to return the patient activity and the care coordinator responsible for that activity. The moment you look at this data, the first thing that comes to mind is that we could easily join on the patient ID, given that it appears in both tables. But the moment we do this, we run into a many-to-many relationship. And here is why. Because you can see that patient 100 was assigned to both Alice Johnson and Bob Smith over time. So the moment you match them using only the patient ID, what happens is that each patient activity is matched to every care coordinator that patient has ever had over time, even if we are not responsible for that particular activity, thereby leading to an inflated number of results. And this happens frequently with most of our reporting system or report that we do. And you have to catch it early in order not to submit false reports. Now, what I tried to do is to understand, given enough context, will the large language model be smart enough to catch this issue without access to our live data? In order to confirm this, what I did was to upload these documents, which you can call it a data dictionary. It contains the column description of the table and also a relationship table to show that this table and that table relate or have something in common. This sort of replaces the semantic model that we saw earlier. Now, I uploaded it to the Google Notebook and prompted. So whenever you upload something to the Google Notebook, it takes the summary of the whole content and present it back to you just to confirm that this is what the document you've provided is all about. Then I went ahead to prompt it to generate an SQL code that returns the patient activity and the care coordinator responsible for that activity. And you can see the way it went about answering my prompt. Not only did it join the patient activity and the care coordinator responsible for the activity very well, but what it did is that it ensured that before it can link a patient activity to a care coordinator, that patient activity must have happened at the time that care coordinator was active. So making sure that that patient activity was carried out by that care coordinator. And all this, the large language model was able to do without access to our live data. But because we've given it enough context, it's able to generate a result that is fairly solid and good in a way. So what is this better self-service approach that I speak highly of? Some of you might have guessed right already in your minds. And the answer is an AI-powered centralized catalog that serves as the knowledge repository for both our business, data, and processes. See it as a semantic layer. We're no longer talking about a model, but a semantic layer that helps everybody in the organization and the AI that we are going to use in our data process to understand the data very well. Now, in this new architecture, instead of consulting a static semantic model, which the previous or the other architecture is doing, what this is doing is that it is retrieving relevant pages of our documents, relevant pages of the catalog in order to answer that prompt very well. But the design behind it is quite complex, as I explained at the event the other day, because then you have to understand when to give the large language model just enough context. You don't want to over bombard the large language model with so much documentation, because then it will end up cherry picking what it wants to use and not necessarily using what you really wanted to pick from that documentation. And in order to do this, one of the person that worked on this project with us is an ontologist expert, was able to develop a framework that ensures at least 85% relevancy match between the prompt and the document being supplied to the large language model. During the Q&A, we could go into details around that design. Now, what are the benefits of this architecture, and what are the benefits of approaching AI implementation in this manner? The first is you have a clear separation of AI and data. I believe that it's very important that AI and live data should live in isolation. Like they shouldn't be in the same environment for now, because we are still at this AI infancy stage, and especially for highly regulated industries like healthcare, you want to be very careful what you're exposed to the large language model. These are people's records, these are people's information, and you want to be very careful not to give the AI access to the large language model. But again, you want to be able to use the AI to gain that competitive edge. So this architecture ensures that you could have your AI workload entirely separate from live data. Another benefit is that it treats the data as a product. Now, remember before we said uh, for data to be treated as a product, it has to be accessible, it has to be trustworthy, it has to be understandable. It's like when you go to the store to buy a product, a tangible product, you want to see the description. You want to see the description around the product. You want to understand what that product is going to do for you. You want to understand the expiring date of that product. There are so many things that covered in that pamphlet that is attached to that product. And that's how we should treat data. And this is what the architecture does very well, because then it collects all these data points, or you could call it the metadata of that data, and present it to the user so that when the user is accessing the data, they are also seeing the whole entire lineage, dependency, understanding what to use, how to use it, the caveat around this data, and the transformation logic behind this data, giving them that power in order to prompt and query the system to provide those answers for them. But every time you provide information or data to an end user, what they want to understand is, okay, this data, where is it coming from? How are you transforming it? How are you calculating it? And it's very important to answer those questions, because those people are the people that understand the data even better than us, the data engineer. Like in the NHS, for instance, a clinician understands the data very well. They are the ones bringing in the data in the first place. They're the one imputing the data into the system. So it is very good to create a system that also allows them to validate the report you are generating, because then they could go back and forth trying to understand the logic behind the report that you're making. The third benefit is it gives that sustainable competitive advantage that I was talking about earlier. And this is because organizations in the same industry likely will be working with the same kind of data. But the main difference, or the thing that differentiates them from other organizations or other companies, is how well they capture, evolve, and preserve the knowledge around the data, how well they can capture their processes around that data. Because then, if you want to go a step further into creating models using the data you have, the success of a model depends largely on the metadata around that data that is being fed to that model or used to train that model. So it's very important that you evolve that knowledge, you document those processes, you begin to capture those processes in a very automatic way if possible. And again, because the architecture and the centralized catalog has a very full context of your data ecosystem, it can generate production ready scripts. It could be Python, SQL scripts, like instantly, because they have the full capture of the entire context. Like if, for instance, you want to generate a script and you go to, let me say, ChatGPT and prompts, can you generate a script that does this? When you try to run it in your system, there is high tendency it's going to give you a wrong result, because it doesn't have the context around the data that you're using. So it doesn't understand all those anomalies that would come into your data, those data quality issues. Like we saw earlier, the issue that somebody was assigned to both Alice Johnson and Bob Smith. So without the context, the large language model would understand that issues like this exist in your database, and it will give you, it will just generate a script for you, but wouldn't necessarily give you the right script to answer that question that you're asking. Another benefit, again, we can see is it preserves knowledge beyond individuals. We are getting to this point where people really stay in the same role for a very long period of time. They tend to move max 2 years, 3 years. And whenever somebody new comes in, it's very difficult for them to understand what is going on in the company, around, especially around the data system. And it is normal, because every organization and company are unique, very unique. So something that you understand about this particular data in the same industry in one company might be fairly different from another company or the new company that you just started working with. And it's very important that you capture the knowledge around this data in a very interactive manner, whereby somebody new can just come in today and prompt the AI centralized catalog, prompt a system that goes back and forth, explaining the process, explaining what this data means, what this column means. If the person asks, for instance, a question, I want to get this column, maybe like, yeah, you could get this column from this report because it has been done and it understands the entire lineage of that report. So you don't need to be chasing people around to get explanation around this process or that process. Immediately you bring in a new team member to your organization, they can start providing immediate making impact immediately because they have the full context around the data and the processes. And lastly is it enables scalability and avoid platform lock-in. Now, with this architecture, you don't need to be creating semantic model like we saw the other time. All you just need to do is to make sure that you are actively documenting, which documentation is a very good thing. And that's the only way to understand that what you're doing is right. Sometimes when you do, or you write a script and you have to document that script, then you find out that you probably are missing something because now you have the idea on paper or you have the idea written down. You can look at it and in a way understand that you're missing something. And it's very important to sort of incorporate that discipline of documentation because that's the only thing the large language model needs from your data system. Tell me about your data in a sense, and I'm going to help you. That's what the large language model is asking for. And again, it avoids platform locking. Now, with the architecture we saw earlier, it has to be whatever Microsoft decide. Any large language model Microsoft decide, large language model provider they decide to use. But with this architecture, you could sort of plug and replace any large language model without breaking a sweat, because then anything that is in the market that is performing good, you could replace with what you have and change it without even stressing. There are so many benefits, but yeah, we'll stop here at this point. Now, let's look at the last topic, which is what you can start doing today. Now, I know in so many organizations, many of us already have like different processes for documentation and what platforms that we're using for our documentation processes. But it's very important that you ask yourself this question. Is the platform I'm using allowing me to capture what I have showing on the screen? Because these are actually what the kind of data the large language model needs, especially when you want to implement AI without exposing live data. You want to be able to give it this context. You want to capture this context over time. And you should start with the data engineer from the bronze layer. The moment you have a project, you're bringing in data. Number one, you have to understand the system where the data is coming from, and you want to document this. This sort of information helps the large language model understand, all right, I've been trained with data on this system before. And when I see that this company is using this system as their upstream system, I understand the kind of data they might be getting. Now, you also want to report that the data extract schedule, in the sense that we run this every day or we run this every hour. The large language model will also have that context that, all right, whenever I'm generating a report, I could also, or whenever I'm generating a query, or whenever I'm giving an explanation, I could also tell the end user that this report runs every morning. So probably at this time, you're looking at yesterday's data. Today's data is not yet ready. The large language model could do that kind of answer, could provide that kind of answers to the users. Another thing is the reason behind the design tools and the tool selection. The architectural design, you want to give a diagram again to explain, just simply put it in a diagram that this system is calling from this system, you're using this system. Just giving that and providing that context in a way that the large language model will have that full context around your data. And it should be the responsibility of, especially the bronze layer, should be the responsibility of the data engineer. Then moving to the gold layer, especially, then you want to bring in the data analyst or the data scientist that will be working with that data in order to understand, all right, what are the governance, what are the usage instructions, what will be the change management, and what are the data quality issues that have been defined. Because at the end of the day, I don't think you can ever get rid of data quality issues, given that most of the systems that we use, there is always human in the loop. So the best thing is just to decide or define what data quality we could manage and how we are going to go around in order to use that data, but also considering that there would always be data quality issues. Now, the question I used to get is most likely a metadata, and I want to explain a little bit more around this metadata description. So the way most likely you see metadata being classified is a business, technical, operational, and referential. Now, the business is the column definition that we saw earlier, like the data dictionary, the overview of that data, sort of the business context of that data. Now, when you move a step further, you now look at the technical metadata. This is where you capture the schema, the constraints, the table definition. You also capture the transformation logic or the lineage logic. Those sort of data is what you capture there. Then the operational metadata is the data coming from the job. It could be from Apache Airflow. It could be from SSIS, anything that you're using or ADF or whatever platform you're using for the orchestration. The log detail coming from those applications will be what is the operational metadata. Then, when I get to the referential metadata, you could also see this as a dimension table that gives more context to the data itself. Because then what happens is that in the system that we're using, somebody could want to understand where is this hospital or the record of this hospital, but in the system we store them as abbreviations. So you want to also give the large language model that dimensional data, which is not like the live data, but the referential data that explains that, all right, when let's say the the user is asking of Bodmin Hospital, for instance, or a hospital in London, Westminster Hospital, that in the system it is stored as WS or PY or something. Given that referential data to the large language model also helps in answering those questions properly. And finally is that you want to assign someone responsible for managing this AI centralized catalog or the catalog you're using in your organization. And the reason why this is because you want to, especially at the early stage, where documentation can easily get forgotten over time while you're still trying to build that knowledge repository. You want to assign somebody solely responsible for making sure that whatever data that is being onboarded into the data warehouse or whatever report that is being generated is fully documented. And following people up to make sure that they are actually documenting this. Because then if you don't assign somebody responsible for it, then everybody might be like, I'll do it tomorrow. And before you know it, another task comes up or another project comes up and they forget to document the first project that they finish or the initial project and just move on with it. And over time, you're beginning to lose that capabilities that the catalog has, because it is using stale data, it's using old data, it's not being updated frequently. So if you don't have like an automatic system that does your documentation for you, you sort of checks what changed over time, you could assign that same person to make sure that any update on any report or any update on any transformation should also go through them so that they can document that process at every stage. Yes, so I'm more than happy to take any questions anybody might have at this point.
Obviously, you've had some experience implementing this in the NHS. What would you say was kind of one of the most difficult parts of doing this?
I think it comes down to the governance, because then before you start this, you have to get your governance right and being able to work out who owns what and what is each of the reports or data set doing. And again, another big challenge was around the metadata itself, like the column description, the data dictionary. Most of the systems, they don't have it. So because we can't expose the live data to the LLM, it would have been easy to use the LLM to generate or to create those metadata, those data dictionaries. But because we couldn't do that, we had to manually write out what those columns are actually doing, because some of the vendors don't provide a data dictionary as part of their contract. I don't know why it's like that, but that was the hardest part, getting that governance ready, because the technology itself, yeah, it's innovative, but again, you just have to give it good data in order for you to get something out of it. And at this point, most of the trust in the NHS are actually still trying to get the governance ready, because how it's very difficult to get it ready to get, okay, who owns what, who owns this data set, or what is it supposed to be, or even the data dictionary for all the data set in a trust system. So it's quite difficult to get that rolling, but I believe that's the hardest part of the entire implementation. Once you get that started, then it becomes very easy to gradually begin to, in a very structured manner, onboard that documentation into the catalog.
Yeah, okay, that's really useful to know. I think it's gonna be the same with, I think, a lot of government organizations and organizations that deal with sensitive data. You can't really get past the governance part. And I mean, you wouldn't want to anyway. Governance is important, but it does, as a developer, I think, and most developers would agree, it's frustrating because it slows things down, but it's incredibly important.
Yeah, it is actually. And I think it's, especially in very big organizations, quite difficult for anybody to want to take the responsibility.
Right, exactly. Yeah.
The stakes are high. You understand, you don't want to have your neck hanging out there in that sense, yes.
Yeah.
Okay.
Oh, we do have one question from Kennedy. Thank you. In a sense, this is retrieval augmented generation RAG in the context of using LLM with data analytics.
Yes, I would say it is, but the difficult thing about the architectural design of this is, how do you actually store the context that the AI is retrieving at this point? Because then, especially with an organization as large as the NHS, there's so many things that are very similar to each other, like so many things. So if you prompt or ask the AI a simple question, it could retrieve like 1,000 related documents. So the innovation is actually in the design of how to store the data itself. But yeah, just like you said, this RAG that we're actually doing. And I believe mostly, yeah, that's what most of the systems will be doing, using that context to answer those prompts.
I think especially with older organizations where they're going to have a lot of departments, lots of kind of documentation sprawl, potentially lots of different ways of doing things. It's what do you give the LLM? How do you choose what to give it? What's going to be good? What's going to be good quality? What's actually going to be useful for it to use? All that stuff. Yeah.
It's one of the biggest challenge, because then the thing about it is that for most NHS trusts, they've not even scratched the surface in the amount of data they are pulling in. They've not, some of them have not started onboarding most data set, because they are still trying to govern the one they already have, and being able to move past that stage of bringing that documentation in and giving the AI access to that context in order to start suggesting ways or recommending ways that they could start implementing advanced analytics in that regards. Yeah. So Kennedy asks another question. How do you store the data for the NHS or a bank? I saw a vector database in your design. So yeah, so the vector database actually doesn't necessarily store the data, the complete data itself. What it actually stores is the overview. So that's where the magic happens in the overview of each documentation, trying to pinpoint an overview to that sense that when you have a prompt, it matches that overview. Then the overview would have an embedding that links to the actual text of the document and the structure in which we are storing that documentation. So the vector database actually holds just an overview. It doesn't hold the entire repository as such, because what this does is that it makes it very easy for you to match an overview to a prompt. Then from that overview, you could link it to the document instantly. I hope I answered your question.
Sorry, go on.
Okay. No. All right, go on, Alex.
I was just going to say, I think the way I think about it is it almost acts like a map, right? That it's what the LLM is allowed to access and how to access it, and then that map points to the documents to get the information out, right?
Yes.
Okay.
We found it very useful today that way, because most times you spend so much time trying to get that format already and sort of parsing the documentation in order to get it in that very structured manner. So the best thing is to use the LLM and generate an overview for each documentation. Then store the overview in the vector database. Then whenever a prompt comes in, it checks that overview and it gets the most relevant overview that answers that prompt properly. Then go back to retrieve the document connected to that overview.
Thank you so much, Stephen, for your time and some really great insight into a real world thing you've done here. So thank you very much.
No worries. It's been a pleasure sharing my knowledge with everybody here.